Hello, in today's video we're going to begin Chapter 8 on quadratics. Today we're going to talk about 8.1, which is graphing a basic quadratic function, or a function in the form a x to the second power. So we'll start by completing the table for the function f of x equals x squared. I've provided a list of x values. We'll go ahead and plug those into the function and obtain the y values. So my first value that I'm plugging in is a -3, so f of -3. Or the y value when I plug in a -3 is -3 to the second power. -3 to the second power is +9. So when I plug in a -3 for x, what I'm going to have is a +9 for y. When I plug in a -2, I've got -2 squared, which is 4. When I plug in a -1, I've got -1 squared, which is 1. When I plug in a 0, f of 0 is 0 squared, which is 0. +1 gives us +1. When I plug in a 2, 2 squared is 4. And when I plug in a 3, 3 squared is 9. So I've got these ordered pairs, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. When I go to plot these, -3, 9 would be here, -2, 4 would be here, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. We have this graph that when I connect the dots, creates a U-shaped graph. We connect it with a nice smooth curve, not straight lines, but a nice smooth curve, creating a U shape. The name for this graph is a parabola. The vertex is the turnaround point, or kind of that high or low point, depending on which way your graph is facing. But this point is called the vertex, and it is at the coordinate 0, 0. The axis of symmetry is the line that splits your graph right down the middle, because it is the same on either side of the graph. The left and the right side are reflections of one another. So I have this line that goes right down the middle. If I were to fold on that line, the left and the right would stamp on top of each other. This line has the equation x is equal to 0. On our next slide, I'm going to go ahead and ask you to create the table again on your own this time. And then I'm going to walk you through a little bit of a shortcut after you've practiced creating the table. So take a minute, pause the video please, and create this table or complete this table on your own. We should have -3. When I square it, we get a y value of 9. -2 squared gives us a y value of 4. -1 gives us 1, 0 gives us 0, 1 gives us 1, 2 gives us 4, and 3 gives us 9. So when I plot these, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Connect our dots in a nice smooth curve to create that U-shaped graph, which we call a parabola. The vertex of this graph is at the point 0, 0, so we're looking for that turnaround point. And from here, we are going to be able to establish a pattern. From the vertex, if I go left 1, I'm going to be going up 1 to get to that first point on my graph. So left 1, I then go up 1. Starting at the vertex, if I go left 2, I'm going up 1, 2, 3, 4, to get to that next point on my graph. So left 2, I go up 4. Back to the vertex, if I go left 1, 2, 3, I would go up 9 to get to the next point on my graph. So left 3, up 9. So we can kind of think of these lefts as x's that we're plugging in. I'm plugging in a -1 and I get +1, -2 and I get +4, -3 and I get +9. All we're doing to those inputs, those lefts, is squaring them, and then we get the up column. On the right, I do the same thing. Right 1, I go up 1. So we think of right 1, if I square it, I get a positive 1. Right 2, I would go up 4. If we think about squaring the 2, that's where our 4 comes from. Back to the vertex, I go right 3 and up 9. So when I go right 3, if I think about squaring the 3, that's where the 9 comes from. So from the vertex, all we're going to do is follow our pattern where we take those left and those right movements and square them to get the vertical movement. So if I were, for example, to go right 4, I would be going up 16. 4 squared is 16. If I went right 5, I would be going up 25. All we're doing is we're taking the right and left movements and squaring them, because that is the rule that we're given in our original function. We'll go ahead and create our table one more time for a function that now is being multiplied by 2. So if I plug in an x of -3, I've got 2 times -3 squared, which is 2 times 9. We need to do exponents first, and I get 18. When I plug in a -2, -2 squared is 4, so 2 times 4 would be 8. Plugging in a -1, -1 squared is just 1, and then I multiply by 2 to get 2. Plugging in a 0, 0 squared is 0, and then 2 times 0 is still 0. Plugging in a +1, 1 squared is 1, 2 times 1 is 2. Plugging in a +2, 2 squared is 4, and then I multiply by 2 to get 8. Plugging in a +3, 3 squared is 9, 2 times 9 is 18. So I plug in the values, -3, 18, which is off my graph, -2, 8, -1, 2, 0, 0, 1, 2, 2, 8, and then 3, 18, which is off my graph again, so I can't graph that one. Our vertex is still at the point 0, 0. In our previous slide, we talked about our pattern. We said our pattern came from taking the x's and squaring them. So if I went left 1, I would go ahead and go up 1. I just take that -1 and I square it. If I went left 2, I would go up 4. I take that -1 and I square it. Left 3, I would then go up 9. Right 1 would be up 1. Right 2 would be up 4. And right 3 would be up 9. So what we're seeing when we do this, from the center, left 1 up 1, left 2 up 4, left 3 up 9, is that it doesn't match with the graph that I have now. It's a little bit wider. So the black graph, the graph that I'm doing now, is a little bit more narrow than my original function. In order to make my original blue graph that I'm erasing transform into the black graph, all we're going to do is take this 2 and multiply all of the up columns by that 2. So initially I had x squared, but now I want 2x squared. So I take this entire column, I multiply by 2, and I get up 2. Up 4, when I multiply by 2, becomes up 8. Up 9 becomes up 18. Up 1 becomes up 2. Up 4 becomes up 8. And up 9 becomes up 18. So then, from the vertex, if I follow that pattern, left 1 up 2, left 2 up 8, left 3 up 18 is off my graph, back to the vertex, right 1 up 2, back to the vertex, right 2 up 8, we see that we are able to create our graph. So what I'm going to do on our next question is actually create the graph without using a table. Our vertex will be at 0, 0. So I'm going to start with my vertex here, and then I'm going to look at my function. My function is an x squared function. So I'll start with x squared. And I'll use that to create my pattern. Left 1, when I square it, I go up 1. Left 2 means I go up 4. Left 3, when I square it, gives me 9, so up 9. And on the right 1 becomes up 1. Right 2 becomes up 4. Right 3 becomes up 9. So my parent function, kind of the most simple version of this function, is x squared. But what we are dealing with is 1/2 x squared. So once we create our pattern, we now need to go multiply everything in that up column by 1/2. So when I multiply by 1/2, up 1 becomes up 1/2. Up 4, when I multiply by 1/2, becomes up 2. Up 9, when I multiply by 1/2, becomes up 4.5. Up 1 becomes up 1/2. Up 4 becomes up 2. And up 9 becomes up 4.5. So all we're doing is we're multiplying the up column by whatever that coefficient is on x squared. From the vertex, we follow our pattern. Left 1, up just 1/2 now. Back to the vertex, left 2, up 2. Back to the vertex, left 3, up 4.5. Back to the vertex, right 1, up 1/2. Back to the vertex, right 2, up 2. Back to the vertex, right 3, up 4.5. And our graph is going to look something like this. So it's a little bit wider than my other two graphs have been. It got squished down about half the height. We'll go ahead and do that a couple more times. We'll use the pattern instead of creating the table. If you're uncomfortable, go ahead and just create the table for each function. My vertex will still be at 0, 0. And my pattern is going to be based around x squared. So I'm going to start with the x squared. Left 1, when I square it, up 1. Left 2, when I square it, up 4. Left 3, when I square it, is going to be up 9. Right 1, when I square it, up 1. Right 2, up 4. Right 3, up 9. And I go ahead and I multiply by the coefficient in front of that x squared. So when I multiply by 4, my up 1 becomes up 4. Up 4 becomes up 16. Up 9 becomes up 36. Up 1 becomes up 4. Up 4 becomes up 16. Up 9 becomes up 36. And then I go ahead and I plot my points. Left 1, up 4. Left 2, up 16 is pretty far off my graph, so I can't graph that one. And then same thing with left 3, up 36. But I can go right 1, up 4. I can't go right 2, up 16, or right 3, up 36. So I go ahead and I just connect the dots best I can, keeping my smooth curve form. From here, we'll go ahead and skip the next one and move on to our next slide, where we now put a negative in front of our x squared. I'll create the chart here and we'll kind of see how this transforms. So negative, and then in parentheses negative 3 squared, means I have a negative, and negative 3 squared is 9, so this becomes negative 9. When I plug in a negative 2, I have a negative, and then my negative 2 is being squared. So I have a negative of negative 2 squared, which is 4, so negative 4. Negative, and then negative 1 squared becomes negative 1. Negative of 0 squared becomes just 0. Negative of 1 squared becomes negative 1. Negative of 2 squared becomes negative 4. Negative of 3 squared becomes negative 9. When I go to graph, I've got negative 3, negative 9 now, so I'm down here. Negative 2, negative 4, -1, -1, 0, 0, 1, 1, 2, 4, and 3, -9. And I connect my dots. So this is still a parabola, and the vertex is still at 0, 0. I'll try connecting those a little better. That vertex is still at the origin 0, 0, but my pattern is going to change. Now what happens is I have an x squared. So I start with left 1 up 1, left 2 up 4, left 3 up 9, and then right 1 up 1, right 2 up 4, right 3 up 9. But I have a negative in front of my x squared. So I'm multiplying everything by a negative. When we multiply by a negative, all that happens is the ups are going to switch to downs. So down 1, this becomes down 4, this becomes down 9, down 1, down 4, and down 9. So from the vertex, left 1, down 1, back to the vertex, left 2, down 4, back, left 3, down 9, and then the same on the right. So a negative in front of your x squared will transform your pattern from ups to downs. So we'll go ahead and put these things together now. I'll start with my vertex still at 0, 0. The only thing that will move your vertex is adding and subtracting, and we'll come to that later. So my vertex is here at the origin, and then I write my pattern. My function boils down to x squared, so left 1, up 1, left 2, up 4, left 3, up 9, and the same on the rights. Right 2, up 4, right 3, up 9. But now I'm going to multiply by that negative 4. So when I multiply by a negative, the ups are going to become downs. And when I multiply by a 4, 1 times 4 is 4. So we're going down 4. Second, when I multiply by negative 4, the up is going to become down, and 4 times 4 is 16. Multiplying by a negative, my up becomes down, and multiplying by 4, 9 times 4 is 36. Multiplying by negative 4, up becomes down, and 1 times 4 is 4. Multiplying by negative 4, my up becomes down, and 4 times 4 is 16. Multiplying by negative 4, my up becomes down, and 9 times 4 is 36. We follow our pattern from the vertex, left 1, down 4. 16 and 36 are too big, so I move on to the next one, right 1, down 4. And then again, 16 and 36 are too big, so I connect my dots. And more or less, here's the graph of my function. Go ahead, take a minute, pause the video, and practice our final quadratic on your own. Our vertex should still be 0, 0. My pattern is going to boil down to x squared. We ignore the multiplication and create our pattern. Left 1, up 1, left 2, up 4, left 3, up 9, right 1, up 1, right 2, up 4, and right 3, up 9. And then we are multiplying by a negative 1 over 5. When I multiply by a negative, my up becomes down. 1 times 1/5 is 1/5. Here my up becomes down. 4 times 1/5 is 4/5. Here my up becomes down. 9 times 1/5 is 9/5. Up 1 becomes down 1/5. Up 1/4 becomes down 4/5. Up 9 becomes down 9/5. You can use a calculator if you'd prefer. And from here I follow my pattern. Left 1 down 1/5, which is very small. Left 2 down 4/5, which is still pretty small. left 3 down 9/5, which is again very small, and then the same on the right. So our graph looks kind of like this. An upside down parabola that just got flattened out. Pretty flat. That brings us to the end of our video today. Thanks so much for watching and have a great rest of your day.